Welcome to my presentation about a project which aims to utilize text mining techniques like text clustering and topic modeling to find terms which are commonly used in a few types of cuisines, as well as analyze how strongly they are associated with other terms. Then predictive models shall be developed with the outputs from text clustering and topic modeling to predict the type of cuisine based on these texture data derived from their recipes. The MS Excel dataset combined recipes consists of 290 recipes for 3 types of cuisines: Indian, Italian, and Thai. The dataset has 4 variables: cereal, ingredients, preparation method, and cuisine. And note that the original binary variables of Indian, Italian, and Thai were combined into a single column as a nominal variable known as cuisine, carrying the labels Indian, Italian, or Thai accordingly. So in SAS Enterprise Miner, we would first import the dataset using the file import node, and upon file import, the variables are edited as shown, and as can be seen, the 3 binary variables are rejected and the cuisine variable is set as the target variable. Next, we attach the text parsing node to the file import node and modify a few parameters like the multi-word term. We add a few terms which are representative of the type of cuisine like olive oil and lemongrass and fish sauce, etc. And under the ignore parts of speech, we added, in addition to the default values, we have added ADV for adverbs and verb as well. Next, the text filter node is connected to the text parsing node, and a few modifications are made again. So important values are the frequency weighting, which is set to log, and the term weight is set to mutual information, as there is a target variable in the dataset. And after running the node, we launched the interactive filter viewer to perform a few modifications. So synonyms like chilies and variants of it are being grouped as one. So review terms to select ones to keep and to deselect and drop using the keep checkboxes. Next, after running the text filter node again, we launch the interactive filter viewer, then right click on the term which represents Indian cuisine and select the view concept links. So the concept link shows that the term Indian at the center is link associated with cumin, which is in turn strongly associated with turmeric, chilies, and ginger, all which are important ingredients in Indian cuisines. So next, for Italian cuisine, we have the word pasta, which is strongly associated with the word al dente, and then also linked to ingredients like olive oil, cheese, and parmesan. Lastly, we have Thai cuisine. So the word Thai is strongly associated with spicy, which is also linked to ingredients like fish sauce, lime juice, and coconut. And for text categorization, we attach the text cluster node to the text filter node and run it with a couple of modifications. So the exact or maximum number is set to exact, and the number of clusters is set to 3, each cluster to represent a type of cuisine. Now the results from running this node shows that cluster 1 seems to represent the Indian cuisine, cluster 2 seems to represent Italian cuisine, and cluster 3 seems to represent Thai cuisine based on the descriptive terms. And next, we attach the text topic node to the text cluster node and make one modification to the number of multi-term topics, which is set to 3 because each topic is to represent a type of cuisine. So the results also appear promising in capturing the characteristics of each cuisine. So topic 1 seems to represent Indian cuisine, topic 2 seems to represent the Thai cuisine, and topic 3 seems to represent Italian cuisine. So next we launched the interactive topic viewer to perform a few modifications to improve upon the text topic modeling exercise. So we do this by first right-clicking on a certain topic text and select current topic, and we will be able to view the terms associated with this topic accordingly at the bottom, and also adjust the topic weight to either include a certain topic by entering 1 or entering 0 to drop a certain term. And then next we amend the topic texts to rename them as Indian cuisine, Thai cuisine, and Italian cuisine accordingly. So lastly we click on recalculate to allow it to take effect. Then we close the interactive topic viewer and save the changes. Then review the results again. So there seems to be an improvement in the way the various topics are being categorized based on the number of terms and the number of document values. Okay, to build the predictive models, we'll need to partition the dataset into training dataset at 80% and validation dataset at 20% using the data partition node, which is attached to the text topic node. So next we attach the metadata node to the text data partition node so as to edit the variables metadata, and these are the variables which are modified. The new row values are updated from segment to input to be used as variables for building the predictive models, which are created using the decision tree technique. So decision tree nodes are attached to the metadata node, and a few modifications are made. Under the maximum branch, we set it to 3, as there are 3 types of cuisines, and the assessment measure is set to misclassification as the target variable is a categorical one. So the 5 decision tree models are created using inputs from both the text clustering and the text topic models as shown below. And we do this by editing the variable within each decision tree node to set the use to yes or no accordingly. So this is the entire SAS process flow diagram. And lastly, we end it with a model comparison node which is attached to the 5 decision tree models. So upon running the model comparison node, it is found that the best model is decision tree number 4, which is based on categorization of terms from both text clustering and text topic modeling segments. So it performs reasonably well with overall risk classification rate of 15%, which is the lowest among the 5 models. So lastly, this is the decision tree built for model number 4, and it shows how the nodes are split based on the clusters and topics derived from the text categorization exercise. So with that, I've come to the end of my presentation. Thank you for listening.